Let's do a new topic in the field of decision science for operations management as our sixth topic. Distribution and network models that in this session we are going to do some sort of introductory materials to get what it means. Mathematical model of distribution and network models. In fact, we are doing chapter 6 of our textbook. Chapter 6, distribution and network models. The first question that may come to your mind is this: what is the difference between network models and the ones we did before? See, when we talk about network models, any definition, because of your experience in real life, you can come up with should be correct. Because, for example, many times in daily life we hear about network of something. What that means? In simple words, networks are entities that have origin and have destination. When we have several origin, for example here 2, 3, and we have several destination, for example 4, and when we connect these things together, as you see in the video, it is called network. So when you have network, it is the matter of which to where, which to start, that is origin, to where, destination, and how much. That's the point. So when we are working on distribution and network models, of course, they have more complexity in comparison to the previous models that we have, but I believe they are simpler in making. You are gonna now have your own idea about which ones are easier. I believe distribution and network models are easier because we can find this area more structured, more organized, and the chance of making mistake is less. So just remember this point so far. When we talk about network models, this is a origin point. There are some origin points, there are some origination points, there are some destination points that you are gonna decide from which origin to what destination in what quantity. So when you check, for example, the GPS, when you want to go from some place to another, quickly find it a network because there are many points to start with. For example, you want to decide about the starting point, there are many, and there are many destinations, and all of the things could be connected. You may tell me now that no, when I'm on GPS there is only one point that is here, but remember we are talking about the next destination. For example, now you are at your home, but when you want to get yourself to, for example, a place that is 30 miles away, there are many stations in this way that when you arrive to each of these stations, they can serve as an origination point, origin point, start point for the next destination. So it forms a network. Okay, we are going to talk about these things and you will completely understand what this area is talking about, and I hope you like it even better than the previous part. Okay, chapter 6 of your textbook, and we are gonna cover 5 topics, 5 sections: supply chain models, assignment problem, shortest route problem, maximal flow problem, and a production and inventory application. There could be some changes in the sections we are covering, depends on the feedback I'm getting, that how much it is easy or how much it is difficult. But for sure, the parts that we are covering is 6.1, 6.2, and 6.3. These parts are covered in this class for sure because of the basic and introductory role they have in the field of distribution and network models. In all these network models, we can categorize them in 3 categories. One category called transportation, that this session we are covering that. Another category is transshipment. The other one is assignment problem. And also we have some other network models that are combination of these things. For example, we have transshipment problems combined with assignment problems. In each of these cases, a graphical representation of the problem can help you so much in better understanding and modeling of the case you are doing. The graphical representation of the problem is called network. That now you should have an understanding of, according to the explanation I just gave you, what network is. We then show how the problem can be formulated. And as I told you about the main difference, the main feature of network models, that I said there is a start point, origination point, origin point, and also there are some destination points, that the points that gives you many options, and also a quantity, a volume that connects these 2 things together. So that's the reason in this slide you see, for example, those that control the supply chain must make decisions such as where to produce a product, start point, where it should be sent, destination, and how much should be produced, the volume part. Whenever you have combination of these 3 variables, parameters, it is a network model. Okay, quickly we start doing an example together, and I believe through doing an example you can learn much better than any other theoretical description first, because we are going to do it step by step and we are going to dominate the concept gradually. Okay, let's read it together. Let us consider a transportation problem faced by Foster generators. As I have always told you, don't get involved with these sentences that carry no value in terms of modeling. So it is just said they have a transportation problem, and this is the name of the company, Foster Generators. And now it is giving you the hint about the fact that it is a transportation problem, because as I told you, there are 3 categories of problem: transportation problems, transshipment problems, and assignment problem. We just reviewed these together. Here it was. And it says here that it is a transportation problem. This problem involves the transportation of a product from 3 plants to 4 distribution centers. So when, my friends, you find something like this, that there is origination points, what are the origination points here? 3 plants. They are origination points, they are start points. 4 distribution centers, destination. Quickly decide that it is a network model. Foster Generators operates plants in Cleveland, Ohio, Bedford, Indiana, and York, Pennsylvania. Oh no, sorry. Foster Generators operates plants in Cleveland, Ohio, one. The other one, Bedford, Indiana, second. And the last one, York, Pennsylvania. So we have 3 origination, or we have 3 origins in our network that are the start points. Production capacities over the next 3-month planning period for one particular type of generators are as follows. So it tells you some information about the origins that were these 3 cities that I just mentioned, and also it gives you the capacity, because still I don't want to spoil the problem for you and tell you what the decision variables are. So just you try to get an understanding of the problem. You have 3 plants. You want to do a planning for the coming 3 months, and the Cleveland plant as origin 1 has 5,000 units capacity, because you have to know how much there is capacity, because it's an origin to send to some destinations to satisfy some demands. The next one, origin 2, Bedford, has the capacity of 6,000, and York has the capacity of 2,500. That totally sum up to 13,500 is the total capacity of production for these plants that Foster Generators have. So just you need to have that. We understand that we have 3 plants. Each of them has different capacity, and we need to do that. Most probably in the next one, we expect to see about the destination points where all these production will go. The firm distributes its generators through 4 regional distribution centers located in Boston, Chicago, St. Louis, and Lexington. The 3 months forecast of demand for the distribution centers is as follows. Boston in 3 months needs 6,000 generators. Chicago needs 4,000 generators. St. Louis needs 2,000, and Lexington needs 1,500. And totally, these 4 distribution centers that are demand centers are expecting to get 13,500 of generators from the plant. Is it feasible? Yes, because we have that capacity, 13,500 capacity for production, so we can cover all this production. So what's the problem? The problem is about something that very soon we will discuss about it, because we have the production, we have the demand that is equal that, so we have no problem. So now here is not about making in a way that cover all the demand, because we already have that capacity. It's about making the best decision. Management would like to determine how much of its production should be shipped from each plant to each distribution center. You remember we had 3 parameters, 3 variables: from where, to where, how much.